Good morning, and as we continue to talk about geometry in this first unit, Introduction to Euclidean Geometry, we're going to talk about measuring lengths. And I have broken this section up into two pieces. The first half, we're going to talk about measuring lengths. The second half, we'll talk about measuring angles. But in measuring lengths, we're going to start talking about how can you find the measures of line segments. And in dealing with distance, okay, distance is always going to be a positive value. And when using the number line, it is best, and I said here, it is best to subtract the smaller number from the larger number. Well, that's a word problem in and of itself. We want to take the large number. In this case, 4 is larger than negative 4, and then we are going to subtract the smaller number. And in doing so, we end up with 4 minus negative 4, which is going to give me again, negative times negative gives me a positive 8. So the distance between point A and point B is actually going to be 8 units. 8 units. Now, I've had some experience with my students having challenges with this because if we just count the number line, we start right here, and then our first step would be 1, 2, 3, 4, 5, 6, 7, 8. And there's 8 spaces between those two. One of the big challenges for my students is they want to start here and say 1, 2, 3. And they get off count that way. But just starting off at this point, my first step would be 1. So this is 0, 1, counting that way. But again, mathematically, if we just take the large number and we subtract the small number, that will give us the distance between those 2 points. And in order to quantify a distance, it's necessary to know the unit of measure. Okay, let's talk about the unit of measure, which is itself a distance. So here, as I talk about looking at these two number lines, and I'm just going to go ahead and draw that down. Right, so that same point would be right here and right here. Looking at that distance is going to make, depending on the number line or the measure, is going to make a difference in the distance. So if I take this first line, it looks like I'm at 3.5 and negative 5. So if I take the larger number, which is 3.5, and I subtract the smaller number, which is negative 5, I end up with 3.5 plus 5, which is going to be 8.5. So the distance between here and here on one number line is 8.5. However, if I look at this other number line, this value right here, I could say that if that's 11, that is going to be negative 10.5. And then this point right here is going to look more like 7. So the distance from here to here is actually going to be 7. It's an ugly looking 7. 7 minus a negative 10.5. And that is going to be 7 plus 10.5, which is going to be 17.5 units. And I did forget my units up here, often overlooked. And in doing so, it just depends on the measure of the line. This is going by different increments than this line. So we have to be cognizant of the measure when we're talking about distance. So let's see. As they tell us again here, measuring segments, the distance between any 2 points can be measured by finding the absolute value of the distance of the coordinates representing the points. So the absolute value. So therein lies that it's always going to be a positive number. So if we look here between points Q and P, we have 35, right? 35 and 15. So we would take the larger number and we would subtract the smaller number, and it turns out that distance is going to be 20 units. And if I look, this is 5 units, 5 units, 5 units, 5 units. So we have to make sure that we're looking at the measure of those. And let's see here. Example number 1 here. Find the length of KM. Now km, it depends. Do we want to use centimeters, millimeters, or do we want to use inches? And as I look at this, I can say that K seems to be 8 centimeters and 19 centimeters. So K is 8 centimeters, or at the 8 centimeter point. M is at the 19 centimeter point. If I were to use this over here, the inches side, that looks like that is about 3 1/8 of an inch, and then this one is approximately 7.5 inches. So what I'm going to do is I'm just going to go ahead and say I'm not going to worry about the inches side. Let's look at what is the length in centimeters, right? So centimeters, we would take M and we would subtract K. So we have 19 minus 8 is going to give me 11. So segment is going to be 11 centimeters long, segment KM. So there you have it, remembering our units. So moving on, now that we've talked about that, how to measure distance, let's talk about the segment addition postulate. And what that says is, looking at this, it says if L is between K and M, right? If L is between K and M on a number line, then KL plus KM, this little piece plus this little piece is going to be equal to the entire piece of KM. So that's just saying that we can combine these to form a larger value. So KM, or KL plus KM is going to, or KL plus LM is going to equal KM. So let's look. The distance, the distance from here to here is 2. The distance from here to here is 7. So KL plus LM is equal to 9. And if we turn around and say, well, what the heck is KM? Well, KM is going to be 17 minus 8, which is going to be 9. There you have it. So it turns out that those two statements are true. So we have here then L is, and therefore if KL plus LM equals KM, then L is between. So again, it's just, we're able to do some segment addition postulate here, or segment additions. And we're going to do a lot of substitution in math, in geometry specifically, because a lot of times our definitions will be our equations, and we're just going to substitute in there. So if we look here at this, I'm going to have to fix this. This should be, instead of find x, that should be RS. So as I look at this, it says points RST are collinear, and we remember that collinear means that they are in a straight line. So I have R, S, and T I put S anywhere. I don't know what the length is. It's just a visual representation. And it tells me that S is between R and T, which is what I drew. And it tells me that RT is equal to 5x plus 5. Okay, so RT, this entire length from RT is going to be 5x plus 1. I think I just said 5x plus 5, my bad. 5x plus 1, right? RT. And then it tells me that ST, this distance right here, is going to be 2x minus 3. And it wants me to find the missing value right here. What is this distance? Okay, so in that addition postulate, if we look at this, we know that according to what we just talked about, that segment addition, we know that RS plus ST is equal to RT. And now what we can do is they want us to find this value right here. And we can just do some substitution. I have, excuse me, I have RS plus ST. ST, they told us, is 2x minus 3. and that is equal to RT, which they said RT is 5x plus 1. Now it looks like I have an equation. So now all I have to do is combine like terms, do my inverse operations, and I can solve for that one unknown value of RS. So here, I'm going to go ahead and combine like terms. I'm going to go ahead and add 3 to both sides. Actually, I'm going to add 3 to both sides. I'm going to do this slowly so as not to skip any steps. So 3 plus 1 is 4. I do still have RS over here plus 2x, and then the reason I added 3 to both sides, right, because I wanted to create 0 so I could move it over to the other side. So there we go. Negative 3 plus 3 is going to give me 0. Now I'm going to go ahead and I'm going to subtract 2x from both sides because, again, I'm trying to create 0. 2 minus 2 is 0. And that gives me, last but not least, just RS now. RS is equal to 3x plus 4. And I'm done. RS is equal to 3x plus 4. I can't go any further because 3x and 4, I can't combine those because I have a variable here and a number here. So RS is 3x plus 4. And if I look, they wanted me to find RS. I found RS. That's all there was to it. So I just did some substitution. I used my definition, right? Here's my definition. Then I used some substitution. Right here, I substituted. I did my inverse operations and combining like terms to isolate my variable, that unknown in this case, and my unknown was RS, and there we have it. So that's all you have to do is write your sentence, write your definition, do some substitution, and then carry on. So looking at this next example, it says points L, M, N are collinear, and M is between L and N. L, M, N. Ln is 21. This entire length is 21. Then it tells me that Lm is 17. Wow, this one seems a lot easier than the last one, but I'm going to go ahead and do that same form, fit, and function that we did before. So I know that Lm plus Mn is equal to Ln. That's my definition, my segment addition postulate. So now I can do some substitution. I know that Lm is 17. I know that Mn is still currently unknown because I'm trying to find it. And I know that Ln is going to be 21. And look, I just did some substitution, and now I have a simple equation that I can solve. I'm going to subtract 17 from both sides because I'm trying to isolate my unknown. And by subtracting 17, 17 minus 17 became 0, so it moves over to the other side. And Mn is equal to 4. There you go. I found the value of Mn. So again, one problem was possibly a little bit more difficult than the other problem, but we used the same techniques in order to solve both of them. And let's see here, example number 4. Well, it says if JL is 5x plus 2, find JL. Well, they gave me some unknown value, and I think when they say find JL, they want to know what the actual measurement of it is. But let's think, what do we know? We have two segments, a point in between, so my segment addition tells me that I know that JK plus KL is equal to the entire length of JL. So I can do some substitution. JK is 27 right here. KL is 3x minus 1. And that is equal to the entire thing. And they told me that JL was equal to 5x plus 2. Now I have an equation set up. I used my definition, I did some substitution, and now I can simplify. So here, let's see, I'm going to combine like terms over on this side first. I can combine that stuff. So I have 3x plus 26 is equal to 5x plus 2. Ladies and gentlemen, I'm here to tell you that the math that we're going to do in this class this year, for this course, doesn't get much harder than this right here. Being able to create a sentence, substitute, and simplify. So here I have this, out of habit, I'm going to go ahead and move my variable to the other side, to the left. So I'm going to subtract 5x from both sides because I want to move this 5x and combine it over here. So in doing so, 5x minus 5x became 0. So on the right, I have 2. On the left, I have 3 minus 5x is going to give me negative 2x. Continuing on, I'm going to continue to combine like terms. So I want to move 26 over to the other side by creating a 0. And I have negative 2x is equal to negative 24, right? 26 minus 26 is equal to 0. 2 minus 26 is going to give me a negative 24. And the last step here, which we haven't had to do up until now, is we're going to divide by the coefficient. And the coefficient is going to be negative 2. The coefficient is that number that is attached to my variable. So dividing by negative 2, divide by negative 2, and x turns out to be equal to 12. All right, I have found x. Now, they didn't say find x. They said find JL. So, but we have something. We know that JL is equal to 5x plus 2. Well, I can now substitute in the value of x. So I have 5 times 12, because I found that x is equal to 12, plus 2 is going to give me 62. So JL is equal to 62 units. Don't know what those units are, but I do know that it's equal to 62 of them. So there you have it as we talk about line segments and addition postulates. Some examples to look back to for our lessons. And then here, some more definitions going into place here. Remember last video I said bisector. We hadn't done a bisector yet. But here we're going to talk about bisecting a segment. And bisect means we're going to cut something in half. Bisect in geometry, we're cutting it in half. So TR is bisected by segment AB, creating two what? If we cut something in half, that means my two pieces are the same. So that is going to be, we are cutting those into two congruent segments, two equal segments. So looking at this, if you can't see it in your paper, that we have segment AB here, right? Here's segment AB, and it bisects TR at point P, and this piece is equal to this piece over here. So it turns out that PT and PR, those two segments, we created those two segments, and we find out that this little tick mark right here means that they are equal. And we're going to see that continuing on in geometry, that means they are equal, they are congruent. And so if P is the midpoint, again, the midpoint is halfway between T and R, then PT is congruent to PR. And PT and PR, what do we know about them? Well, we know that they are congruent halves of one whole, and then we know that since they're congruent, that they have equal lengths, because that's what congruent means. Congruent means they're going to be equal. They're the same. And then if things are congruent, then their measurements are going to be congruent. So there you have it. Each smaller segment of a bisected segment. So when it's bisected, that means we are cutting it in half. So is 1/2 the length of the longer segment. So if we, in this case, using this example, we know that PT, right, is equal to PR, which is equal to 1/2 of segment RT. So that's just looking mathematically at what a bisector is, what the midpoint means, and so forth and so on. So here, if we take this and we try to do an example, and it says point B is the midpoint of AC. So now it's a little bit more specific. Here, I have AC, segment AC, and then it tells me that B is the midpoint, which means if it's the midpoint, these two pieces are congruent and equal. So I know then that doing some substitution, now it tells me that AB is 27. 27 tells me that BC is 3x plus 6. Okay, it says find x. Well, looking at what I know, if this portion is equal to 27 and this portion is equal to this, okay, oops, let me erase that so it doesn't distract us. If AB is equal to BC, because then I can do some substitution. AB is 27. BC is 3x plus 6. Look at that, I have an equation. Here's my definition of a midpoint and congruency. And then I did some substitution, came up with an equation. Now all I got to do is simplify. So let me go ahead and subtract 6 from both sides so I can combine like terms. That became 0. So I have 3x is equal to 21 divided by the coefficient of, and then x is going to be equal to 7. X equals 7. There you go. We just used some of the definitions to write an equation and solve. Some of you are going to hate it. Almost every problem in geometry is a word problem that we had to use our definition and do some substitution. So, in a sense. So, looking at example number 5, point Q is the midpoint of PR. Okay, point Q is the midpoint of PR. So that tells me that if this is my midpoint, then this segment is equal or congruent to that segment. Now it says find the value of x. Well, shoot. I know that PQ is equal to QR. Now I can do some substitution. PQ is the value of 7x minus 16, and that is equal to QR, which is 4x plus 2. And there it is. I did that substitution. Now I'm in a position where I can combine like terms and solve for an unknown combine like terms. I guess really when you get to this point, you should be thinking, I should combine like terms. I have some variables and numbers over here. I have some variables and numbers over here. That means I need to use my inverse operations to get them combined into the smallest thing possible. So let's see. I'm going to go ahead and add 16 to both sides because I'm going to, move 16 away. So moving 16 over there, 16 minus 16 is 0. So I end up with 7x is equal to 4x plus 18, because 16 plus 2 is 18. Now, to get my variables all together, I'm going to go ahead and subtract 4x from the left and subtract 4x from the right so I can get all my variables onto one side. So 4 minus 4 became 0. So I have 3x is equal to 18, and if I go ahead now, I can divide by my coefficient to isolate my variable, and x is equal to 6. There you go, x is equal to 6. Again, using my definition, doing some substitutions, and some simple equation inverse operations. So that will help us moving with today's assignment where we were working on segment lengths.